Now we're going to switch gears and our final speaker of the research portion is Kurt Smith with the University of Wyoming, and we are going to hear a little bit about his research. Go ahead, Kurt.
Great. Thanks, Claire. While I get this loaded, I'll introduce myself a bit more. I'm a research scientist at the University of Wyoming. Let me just give me one moment here to get oriented. All right, so quickly like to point out Brian Mailer and Jared Merkel. They were both pretty instrumental in this work to help us think through some of this issue. So as Claire mentioned, I'm going to talk about deer and invasives and what we've learned over the last year or so. So I've got to start a little broad here to set up our research. So this is in fact a deer talk, not sage grouse, but sage grouse were probably one of the more consequential species, bringing sagebrush to the policy forefront. So in 2010, when grouse were petitioned for listing, that really brought a lot of partners to the table to enact policy and new conservation actions that ultimately led to sage grouse not being listed. Issues to the sagebrush biome are really largely framed as a species-centric approach. So the issue there, though, is that not all people living and working in sagebrush really care about these charismatic species. So approaching the problem from an ecosystem down, so to speak, is going to bring as many stakeholders to the table as possible. And so we have these large-scale frameworks like the sagebrush conservation design, and this was designed as a strategy to proactively manage. So rather than focusing on highly degraded sites that are unlikely to respond to management, we're putting our efforts in areas that are most likely to respond. So these really align well with the concepts of defending and growing the core. And was also mentioned, this has recently been adapted with invasive grasses in mind. So what I'll call the strategic invasive grass framework, recently developed by Chad Boyd and his colleagues. And that essentially has some categorization. So maintain, improve, and contain areas. And so a similar framework to focus efforts in areas that are most likely to respond the way we would like them to. But the effectiveness of these landscape strategies to simultaneously benefit wildlife are really, for the most part, unknown. And my argument here is a bit circular, but for these to be effective, we do need to know how species respond to these landscape level frameworks. And of course, charismatic species are really helpful in helping tell those nice conservation stories. So getting into big game in invasive grasses, there's truly a lack of research out there that allows us to understand how wildlife in general and big game in particular are interacting with habitat that has been invaded by invasive grasses. So Western big game, including mule deer, rely on sagebrush throughout the year. And of course, mule deer have declined, and there's been a lot of conservation concern in their arena. This trend line here is showing population trends in Wyoming from about the 1980s, and from 1990 on. So when populations were thought to have peaked in the 90s, we've seen a pretty steady decline since then. So of the 37 herd units within the state, there's not a single one that's above objective. So that's pretty concerning. And broadly, a lot of these issues with deer are related to habitat loss, fragmentation, and degradation, but there certainly has been a lot of work to conserve critical habitats, but until more recently, we don't have a good understanding of how invasive annual grasses are impacting deer habitat. So there are many reasons to be concerned. So invasives generally have lower nutritional quality than native vegetation. They can also green up and then senesce more rapidly than native perennials. And that has some pretty important implications for deer's ability to track resources. For example, in the spring, when deer are known to surf that green wave or that resource pulse, the mismatch in timing could decouple the ability of deer to get those resources, which has some important implications during those critical time periods. Probably more importantly is that once invasive grasses reach that sufficient level, we could see a annual wildfire cycle that could ultimately lead to a more permanent invasive annual grass state, and that often lacks the woody vegetation, so the sagebrush and other shrubby species that deer rely on. So our work here was overall to get a better understanding of deer seasonal resource selection in relation to invasive grasses. And then we took that information and forecasted it with two different management scenarios to see what deer habitat might look like in the future. And we used those broad scale frameworks in our analysis as a way to place these findings in context with those. So the study was east of Buffalo, Wyoming, so the northeast part of Wyoming. And that area is characterized by a mid elevation sagebrush and sagebrush associated grassland. This photo here is probably a good representation of the area, at least before a big fire that came through. And I'll briefly mention that at the end. But there are lots of invasive grasses in this region. So this photo was taken on a partially reclaimed gas road. You can see a lot of annuals here in the foreground and then interspersed in the background. So for this study, we used deer data collected by Hall Sawyer from West and the Wyoming Game and Fish Department. So they actually collected this information for other reasons. They were looking at migration and herd interchange up in this area, as well as trying to key in on some highway mortalities. But they were generous enough to allow us to use this information for this work. So we have data from 115 deer from 2019 to 2022, and those animals collected locations about every 2 hours. So a pretty rich data set here. So for our first objective, we used a really simple used availability framework where we're contrasting used locations compared to where animals could go. So available locations within animal seasonal ranges. And of course, we're primarily interested in how they're responding to annual grasses. So we use the range analysis platform remotely sense data for that. And I'll mention, without going into much detail, we also included a lot of other environmental covariates that are known to influence how deer select the landscape. And then to get at our forecasts, we predicted that resource selection model to the landscape, and that allows us to spatially understand areas where deer may be selecting or avoiding. And we simply took all of those deer seasonal ranges and combined them together to come up with an overall study area where we made those predictions. So here I have the summer resource selection function. Without going into depth, it's just simply showing relative probability of selection where the areas of warmer colors in red are showing low predicted selection. And then as colors get cooler, those are areas that we're predicting to have higher selection. But with our forecasting, we essentially left and assumed that other environmental covariates would remain the same over a 20-year period. And then we allowed annual grass and perennial grass to change based on two scenarios. So our first scenario was a do nothing scenario. So here we took and looked at the rate of change in annual and perennial grass over time in the past and used that to forecast what things might look like in the future. So we used RAP data from about 2002 to 2022. And at each pixel, so each 30 by 30 meter pixel within that study area, we calculated a slope to get the rate of change over that time for both of those estimates. And then we use that again to project into the future to see what things might look like with no management. And then on the other hand, we looked at targeted management. So in this case, we assumed that any location within this study area that had greater than 15% invasive cover based on 2022 RAP estimates were going to be targeted for treatments. And under that scenario, we zeroed out those pixels that had annual grass greater than 15%, and then we replaced annual cover loss with perennial cover in those instances. And in areas that weren't targeted for treatment, we made the same assumption that the rate of change in annual and perennial in the past would correspond to what things might look like in the future. So our scenarios are a touch more complicated than I'm discussing here, but we do rely on a few simple assumptions that are used to forecast a highly complex ecological issue. So that's something worth noting. And then to make our comparisons, we simply calculated percent change between future and current conditions. So jumping into the resource selection results, across all seasons, we see that deer are responding to invasive annual grasses in a nonlinear pattern. So here I have relative probability of selection on the y-axis of this chart, and then invasive annual grass cover on the x-axis. So from about 0 up until roughly 10 to 14% cover, depending on season, we see that deer are selecting those areas. So no avoidance until we hit that point, and then there's a pretty steep decline in our predictions where deer begin avoiding, and then there's really strong avoidance once we exceed about 20% cover. And as a bit of a validation there, we just looked at the deer data, and less than 5% of all deer locations used or were recorded in areas with greater than 20% cover. So pretty compelling evidence that deer are not really using areas that have a lot of invasive grasses. For our forecasting, if we do nothing, we expect that about 75% of the study area will have greater invasive cover 20 years from now. And in regards to deer, under that scenario, we're expecting to see a large decline in predicted probability of selection over about 60% of that area. So these are the areas where resource selection is expected to see greater than 50% decline as a result of that increased grass abundance. And those areas, importantly, primarily fall in that improved priority area under the invasive grass framework. So those are the areas that those landscape models are predicting could actually benefit from treatments and might respond favorably. But on the flip side, if we do target management, we would expect to treat about 50% of this area. So that's a large area. It corresponds to roughly 200,000 hectares. But for deer, and under that scenario, we expect a large increase in predicted probability of selection. So we could really be improving deer habitat in this area. And the largest increase is expected to occur in that same improved priority area that we might expect would respond favorably to management. So in summary here, deer avoided invasive grass cover. We see a really strong avoidance after cover exceeds about 20%. And that corresponds well to what we might expect based on the nutritional quality of invasive grasses for deer and the way that they rapidly senesce more quickly than native vegetation. And this is interesting in that it responds pretty closely to some literature showing that is roughly the point where invasive grasses begin to shift towards a more invasive dominated community. So these frameworks appear to be working based on our initial results. If we adapt these frameworks to mule deer, we could see some benefits. And as I did mention, there's a lot of uncertainty with our forecast and some of the assumptions we have to rely on, but there is a nugget of hope here. So a recent observational study in Colorado had some trail cameras out in both untreated areas and areas treated with indaziflam, and they saw an increased use by deer in those treated areas. So here I just have a use metric from that trail camera footage on the y-axis over time during one winter, and across the board there was more use in the treated areas. So not a lot of evidence to draw from, but a bit of confirmation that what we're seeing might possibly be reflecting reality. So I just wanted to mention a future direction. So in 2024, unfortunately, the House Draw Fire came through, and that certainly has some big implications for this landscape. But as a result of that, there was a lot of effort to treat invasive grass both within and adjacent to that fire, and there's some more treatments in the works. So we do have that deer data set from 2019 to 2022, and some of those deer overlap with this area. But just about a month ago, we collared an additional 75 deer to try to address some of these questions and learn more about this issue with deer. So hopefully that'll be something I can share in the next couple of years, some of our preliminary findings there. Thanks a lot for letting me be here today. It was nice to talk about this work, and I think Claire put it in the chat, but we just have a working land for wildlife science to solution summary on this effort that might be informative for those folks that would like to hear more. Appreciate it.
All right. Thanks, Kurt. So we do have a couple minutes. We have about 6 minutes for questions. So our first question that we have is, do deer or other large game species have a role in spreading invasive annual grasses in their movement across the landscape? And if so, how might we think about mitigating that?
That's a great question. Yeah, certainly they do. I don't know the extent of, but there can be spread through, seeds being caught up in fur on legs or between hooves. And I don't know how viable invasive grass seeds are if they go through the digestive system, but they could potentially be spread that way. And I don't think I want to touch the idea of trying to prevent that spread with animals because I just don't know what that would look like.
Mm-hmm. Nope, that's very fair. Alrighty. Do you have any plans to look at forage quality within your treated areas for mule deer?
Yeah, I think so. That's something that we have on the agenda to discuss. And, you mentioned that animals or deer will eat invasives during periods when it's green. And so understanding how that nutritional quality is in relation to native perennials will be really critical to better understand the responses to treatments. But stay tuned there with how we come up with ways to develop that question more thoroughly.
Mhm. Awesome. Well, we have no more questions at this time. So we want to thank you for your time, Kurt. We're going to head into our break a little bit early, so please be back here promptly at 10:30, and we will then begin our land management section.